Hello everyone, in this video we're going to talk about dividing polynomials. So let's get started. Let p of x and d of x be polynomials with d of x is not equal to 0. Then there exist unique polynomials q and x and r of x such that p of x divided by d of x is equal to q of x plus r of x divided by d of x, or the equivalent form of that, p of x is equal to d of x times q of x and then plus r of x. Now, what does this mean, and what should this remind us of? Recall when you did long division just with numbers, right? Like when you divide 5 by 3, let's say, right? We call 5 the number we're dividing. We call it dividend. Some call it dividend. I like to call it dividend. And we call 3 the divisor, what you're dividing by, right? So again, what you're dividing is the 5, the dividend. What you're dividing by is the divisor, 3. The answer that you're getting, the answer to a division problem, which in this case is 1, that's called the quotient. And then here 1 times 3 is 3, and then I have a remainder of 2. What's left is the remainder. So that's where we get those P, D, Q, and R from, and of course here the format, right? So to find, right, the original polynomial, the dividend, the 5 in this case, it's kind of like saying, it's very similar to saying 5 equals, right, the divisor, which is what, 3, and the quotient, which is the answer, times 1, and then plus 2, right? Or in other words, this is like saying, if I want to put it in this first format, if I divide 5 by 3, right? Let me write it on top here. 5 divided by 3, I'm going to get an answer of 1 plus what? A remainder of what? A remainder of 2, but this remainder of 2 is 2 out of what? 2 out of 3. It's 1 and 2/3. Okay? So these are two forms or two ways of writing division, and it's similarly, it applies to polynomials. So now we're going to extend this knowledge to polynomials. So p of x is the, as we said, is the dividend. And d of x is the divisor. Q of x is the quotient. And r of x is the remainder. Now note that the degree of r must be what? Less than, strictly less than the degree of p of x. Just like the remainder is always less than the divisor. Now when you're dividing polynomials, the degree of the remainder, right? The degree must be what? Less than the degree. It should be less than the degree of the divisor. Okay? So just make sure, because if you're dividing by 3, you cannot have more than 3 left. Okay? And of course, it'll be less than what you're dividing by. It'll be less than 5 as well. So let's try long division. First example, 6x cubed plus 4x squared minus 3x minus 8. All that quantity divided by 2x squared minus 1. So the setup is 6x cubed plus 4x squared minus 3x minus 8. All that divided by 2x squared minus 1. And so how does it work? You first check to see how many times does 2x squared go into 6x cubed. This is the procedure, okay? And then it does go into a 3x time. And then you take the 3x and then you multiply it by the entire divisor. And this gives you 6x cubed, right? And then minus 3x. And then just like you did with traditional division, you're going to subtract, aka switch the signs. So the 6x cubed must cancel out. They'll cancel out. If you did not choose this correctly, the 3x, then they would not cancel out. So it's important to know what you're dividing by and how much you're getting. And then this ends up, and also the 3x is here. They happen to cancel out. This leaves us with 4x squared minus 8. And then same idea. How many times does 2x squared go into 4x squared? The answer is 2 times. So it's plus 2 here. And you get 4. And then you multiply this by this whole thing. 4x squared minus 2. And then you subtract, aka switch signs. So minus plus. The 4x squared cancel out, and you have a remainder of negative 6. So how do you formulate the answer? How do you present the answer? You would say this whole thing equal to, let me see if I can move this to the side here. Right. you can say this is equal to, what? 3x plus 2, and then what? Minus or plus minus 6, because that's the remainder, minus 6 or plus minus 6 divided by 2x squared minus 1. Okay, and this is your answer. So that's for number 1. Now, is 2x squared minus 1 a factor of 6x cubed plus 4x squared minus 3x minus 8? No. The answer no is no. It's because your remainder is not 0, right? And you can say, to justify, you can say because of what? Because r of x is not equal to 0. Now, going on to number 2, negative 13n plus n cubed minus 12, etc., right? First things first, make sure you rearrange this in order. So this is the same as saying in order, in descending order of degrees, basically. N to the third power n cubed minus 13n minus 12, all of that over n plus 3. And let's do long division. So let me do it here maybe. So n cubed minus 13n plus minus 12 and divided by n plus 3. So you get n squared, and then n squared times n plus 3 is n cubed plus 3n squared, and then you subtract. When you subtract, let's change sign, then cube cancel out. You'll get negative 3n squared minus 13n minus 12. And then how many times does n go into negative 3n squared? The answer to that is negative 3n. How many times does n go into 3n squared is negative 3n times. So negative 3n squared minus 9n, then again switch signs. This is plus, this cancels out, and you have negative 4n minus 12, and then you can see that this is going to go what? Negative 4 times, because that's going to give you negative 4n minus 12, and when you switch signs, you'll get plus and plus, so they cancel out, and leaves you with 0, right? So yeah, to answer the question on the right is going to be a factor, but let's first formulate the answer, or write the answer in the correct format. So this ratio here, dividing these two polynomials, is going to give me what? The quotient, which is n cubed n squared minus 3n plus 4 right here. 3n minus 4. Okay, and there's no remainder, so this is it. Now, is n minus 3 a factor? As we said, yes, it is. And you can say what? R of x is 0. That's the reason. That's the justification for it. Okay, or since R of x is equal to 0, comma, therefore, or then, n minus 3 is a factor of negative 13n plus n cubed minus 12. Okay, so that does it for these two examples. Let's do one more here. Let's divide these two. What I would like you to do as you're watching these videos is to pause and attempt these questions and try them on your own and see what you get, and then play and see how our answers match, or right, if there's a mismatch, and then work on that. Okay, that's number 3 now. So we're doing 50 x cubed plus 10x squared. I'm just checking to make sure that the terms are in descending order of degree. And this gives me first, so 5x goes into 50, 10x squared times, right? And then if you multiply, you get 50 x cubed minus 10x squared. Switch sign, negative, positive. This cancels. Then you get 20x squared minus 39x minus 4. And then 5x goes into 20x squared 4x times, so plus 4x, 20x squared minus 4x. Switch sign, negative, positive. This cancels out. Negative 35x minus 4. And then 5x goes into negative 35x, negative 7 times. You get negative 35x, and then plus 7. And then if you switch sign here, negative, positive, negative, and you'll get you'll get negative 11. And that's your remainder, okay? So the answer to this is what? Is 10x squared plus 4x minus 7, and then minus or plus minus 11 divided by what? Whatever you're dividing by, the divisor, which is 5x minus 1. And this is your answer. Okay? So is 5x minus 1 a factor? No, it's not, okay? That's for long division. Let's move on now to synthetic division. So synthetic division, it's another way to divide. Some students, or I would say generally speaking, most students find it faster. Now be careful on homework or assessments. If you're being asked to do a long division and using one method, you have to go with that method. If you're given no option, or you're not, the question is not specific about which method to use, then you're free to use long division or synthetic. But you cannot do synthetic when being asked to do long division and vice versa. Now, synthetic division is a simplified form of division which can be used when a polynomial p of x is divided by a linear factor in the form of x minus c. So let's say you're dividing by something like x plus 6 here, right, or x minus 5. Okay, so it works here, it works here. It could also be in the form, we'll get to that in a moment, it could be something in the form of ax minus c, right? It could be like 2x minus 5. You can still do it, okay? But let's start with just the form of x minus c. So how does it work? The way you set it up, you create a little box here. So you're dividing by x plus 6. That means negative 6. You're trying to see if negative 6 is a root, right? Because you're trying to divide by x plus 6 to see if that's a factor. So you place the negative 6 here, and then you have to be careful. You have to always make sure that your polynomial is in descending order of exponents. So x cubed, x squared, x, and then constant, that's fine. And then with that said, you're going to place here the coefficients of these terms. So 1x cubed, that's 1. Then 5 for the 5x squared, then negative 3, and then negative 4. And then you place a kind of like a fraction line, but it's really not a fraction line, with a little bit of separation here because you need to have some numbers. And then you bring the 1 down, you multiply the negative 6 by 1, you'll get negative 6, and that's what you place. That's where you place it. So again, the 6 goes here, the coefficients go here, a little bit of separation with a line, and then you bring the first value down, and then you multiply this value by that value. Okay? And this gives you negative 6. Then you add 5 and negative 6, you get negative 1. Then you again multiply negative 6 by negative 1, you get 6. You add negative 3 to 6, you get 3. Then you multiply negative 6 by 3, you get negative 18. And that basically gives you a total of negative 22, which is your remainder, by the way. Okay? This is your remainder. So when you're dividing, right, remember, you're dividing x cubed, the highest here is x squared, or is x. So you're going to get something x squared. So these 1, negative 1, and 3, what do they represent? They're literally 1x squared minus x and then plus 3. And then with the remainder. So the answer to this is x squared minus x plus 3, and then plus what? Plus minus negative 22. So negative 22 divided by what you're dividing by, which is x plus 6. Okay, so you can try number 5 on your own, and then you can pause and try and then play. So for number 5, again, the setup goes negative 3, 1a cubed. Careful, no a squared, so you put a 0 for that, which is the same as saying 0a squared. You have to account for every single coefficient of every single term with exponent descending order, even if that term does not exist. Even if I don't see an a squared, it's really 0a squared. And then minus 13, minus 12. Line, bring the 1 down, multiply negative 3 by 1, you get negative 3, add them up, you get negative 3. Multiply again, you get a 9, negative 4, multiply negative 3 by negative 4, and you get positive 12, and that's the remainder of 0. So remember, you're multiplying this by this to get it here, this by this to get it here, right, etc. This is the remainder of 0. So yes, a plus 3 is a factor of a cubed minus 13a minus 12. And I need to make sure that I need to write an answer, right? What's the answer? So remember, you're dividing a cubed, the highest, by a. So you're getting a squared. So this is basically a squared minus 3a minus 4. So the answer here is a squared minus 3a minus 4. You don't have to write it twice here and here, but just to know what the answer means, okay? Now, any questions here? Bring them to class, right? Put notes here, use this space here for your notes. If you need to, remind yourself of something that I said, especially when I'm doing these videos. What if we want to divide by a linear factor of the form ax minus c? And the example, going back to example 3, it says divide 50x cubed plus 10x squared minus 39x minus 4 by 5x minus 1. So just keep in mind now, when you're dividing by 5x minus 1, you are, in a way, you want to find the root of that, right, which is 1/5. But you have to be careful here. You have to treat the 5x, just the 5x minus 1, as 5 multiplied by x minus 1/5, right? So that's how you know, if you were to take this back to the x plus c or x minus c form, you know the what makes it 0 is 1/5. And then we'll talk about what happens to this 5 later, right? So now we're divided by 1/5 here. We have 1/5. And we're taking 50, remember 50x cubed is 50, then 10x squared is 10, then negative 39x is negative 39, and minus 4, it's a minus 4, and create a little space, bring the 50 down. 1/5 of 50 is 10, add them up, that's 20, 1/5 of 20 is 4, add them up, is negative 35, 1/5 of negative 35 is negative 7, add them up is negative 11. Now, we are not getting, if you're here and you know this is really your quotient, the 50, the 20, the negative 35 are not quite what we got here. Even though the remainder looks fine, right? The remainder looks fine, but the quotient is not the same. And the reason is because we took this 5 out. So in a way, this should be negative 11. In a way, because we took the negative or the 5 out, we have to go back and compensate for that. So I have to divide all this here by 5. So this becomes 10, 4, and negative 7. And now if you see 10, 4, and negative 7, those match the leading coefficient, the linear coefficient, and the constant, okay, respectively. So with this in mind, we can say what? We can say this division here is equal to, right, equal to 10 x squared plus 4x minus 7 with a remainder of what? Of 11, negative 11. So plus minus 11, negative 11 over 5, or divided by 5x minus 1. And if we look back, it should be the same answer as we got in number 3 with long division. I hope this was helpful. Thank you for watching. Again, please make sure in the future you pause, you try on your own whenever possible, and then you watch the question being solved by me and compare notes. Have a good one.